The sides of a rectangle are measured to be a equals 2.5 centimeters plus or minus 0.1 centimeter and b the other side 5.0 centimeters plus or minus 0.1 centimeter. Find the area A of the rectangle. Let me remind you something. Steps to find a value and its uncertainty. First, set aside the uncertainties and find the value. Go directly through the equation rho equals m over v, t equals 2 pi times square root of L over G or any other complex calculation. Directly, please find the value. But the second step could be finding the uncertainty. The second step may be something like this. If your calculation contains only plus or minus, only addition or subtraction, in such cases, first you have to find the absolute uncertainty, then the fractional one if necessary. But if your calculation contains multiplication and division, you have to find fractional uncertainty at first, and the second step could be the absolute uncertainty if necessary. Here, the area of a rectangle could be product of A and B, the two sides, okay? I substitute the values. Pay attention, the two uncertainties here, 0.1 for the first one and 0.1 for the second one, are not considered at all. First, I'm concentrated on the values 2.5 and 5.0, and then the answer is 12.5 centimeter squared. But this answer has a problem. You know that according to the rules of significant figures, the first term contains only two significant figures, and the second one, of course, contains only two significant figures. But the answer has three significant figures. It's not accepted. It should be rounded up or rounded down to reach only two significant figures. 5 is something to be extracted. But if I set aside the 5 or greater than 5 could be rounded up. So it's going to be 1. So 1 unit is added to 12 and the answer is 13 square centimeter. Okay, it is okay now for the value, but the uncertainty. For finding the uncertainty, as you know, the calculation contains multiplication. So I'm going to find the fractional uncertainty. How? Delta A over A equals delta small a over A plus delta B over B. A at the denominator here is something that previously has been calculated. This is 13. I have it. Okay? A is the length of a side. This is 2.5 as it's given here. B is the length of the other side. It's given here. But delta A and delta B. Delta A is 0.1. Delta B is 0.1. They are substituted. And the calculation will give us delta A is equal to 0.78. Okay. This is the uncertainty, but it's not in agreement with the orders of the figures in the answer. The value is 13. The last figure, the last right figure is 3, and in the order of ones. But here, the last figure is in the order of hundreds. It's not accepted. The whole number should be rounded up to reach to the order of ones. So ignore the 8 and be concentrated on 7 in the order of tenths. 7 is greater than 5. It's rounded up to 1. And so delta A is equal to 1 centimeter squared. So here the uncertainty of the area is 1 square centimeter. Despite of 0.78, all the two figures have been converted to 1 because we must round it up to reach the same order of magnitude for the last right figure of the value. 3 here, which is in the order of ones. So the final answer could be A is equal to 13 square centimeter and plus or minus 1 as its uncertainty.